I'm Tara Moran, CEO of the California Water Data Consortium. And for those of you who may not be familiar with the consortium, we were founded in 2019 to support implementation of the Open and Transparent Water Data Act, commonly referred to as AB 1755. And as all of you well know, data can and should be at the heart of informed water management here in California and beyond. And that really is the vision for the consortium, which is really with active involvement from state agencies, NGOs, private sector, tribes, academia, and many others, is really to support the development and improved accessibility of high quality, trusted water data to support better outcomes for everyone living and working in California. And so the goal of our Data for Lunch series is to learn about new and innovative water-related data methods and technologies, but also to provide a venue to learn from and connect with one another. And so we're really excited to have Dr. Tony Hale from the San Francisco Estuary Institute here with us today. And he's going to be talking to us about a program monitoring trash using unoccupied aerial system-based imagery. And this work was done in partnership with the Southern California Coastal Water Research Project with funding from the Ocean Protection Council and the California Department of Public Health. And in addition to serving as a proof of concept for aerial trash detection, the project also provides opportunities to explore broader applications of such technologies for natural resource monitoring, as well as data management more broadly. And so I'm really excited to hear the conversation, both the presentation itself as well as the follow-up conversation. And I always enjoy hearing from Tony because he really does do such cool projects that meet a specific need, but also he's constantly thinking about how can this specific tool or method or technology really have broader implications for us, and really always thinking through that. So really looking forward to the discussion here today. I'm also really happy to introduce Dr. Meredith Lee, who will be formally introducing Dr. Hale in just a moment and co-moderating the discussion with me here today. So Dr. Lee is one of the consortium's board members and is the Chief Technical Advisor at UC Berkeley Division of Computing, Data Science, and Society. Prior to her current role, Dr. Lee was the founding executive director of the West Big Data Innovation Hub, where she and her team launched public-private partnerships, including with the Department of Transportation, Department of Homeland Security, US Census Bureau, as well as with many academic institutions, industry, and state and local government. Her expertise and enthusiasm have really made her such an incredibly valuable member of the consortium. And so before I hand things over to Meredith, I just want to run through a couple of housekeeping items. Our next Data for Lunch is on August 18th from noon to 1 with an additional 30 minutes of informal discussion. And this presentation will be with Sarah Musiker, Joe Facio, and Peter Mayer from Flume. And if you have any suggestions for other Data for Lunch topics, please reach out to either myself or Amanda Miller, and we'll go ahead and drop that contact information into the chat here. For the flow of today's meeting, after the introduction by Dr. Lee, we'll hand things over to Tony Hale, who will give about a half-hour presentation. We'll follow that up with some sort of formal Q&A. Meredith and I will be moderating those questions, so please go ahead and drop any questions that you have into the chat. Be sure to include your name and affiliation. Alternatively, please feel free to raise your hand and then we'll ask you to unmute yourself to ask your question. So we'll be tracking those as well. Similar to our last event, Dr. Hale has agreed to stay on Zoom for informal discussion after that sort of formal Q&A. So for up to half an hour, up to 1:30. So excited to have that as well. And then, as I mentioned earlier, our slides and recordings will be available on our website after the event. And so with that, I will hand things over to Meredith.
Wonderful. Thanks, Tara. Hi, everyone. I'm excited to join Tara and the consortium and welcoming all of you to the Data for Lunch series. I'm particularly pleased to introduce Dr. Tony Hale as today's featured speaker. Tony's full bio is in your meeting invitation, as well as on the cawaterdata.org website. You may have noticed he's worked in a wide range of organizations, from being a tech consultant while completing his doctorate at UC Berkeley, go Bears, to his role as IT director at Mills College, and head of the enterprise applications team for Peralta Community College, which is the second largest educational organization in the San Francisco Bay Area. From an environmental sciences space, Dr. Hale has served as a member of several state level committees, including the California Coastal and Marine Geospatial Work Group, the Data Management Work Group, and currently the Trash Monitoring Work Group. I'll personally also note I really appreciated working alongside Tony, whether it was a trash hackathon, all one word with the hashtag, through partnerships for the California Water Data Challenge, or many community brainstorming sessions, sometimes in completely windowless rooms. You can immediately get a sense of his dedication to the cause and his role as a thoughtful, innovative, and supportive mentor in these types of community engagement activities. Through the California Ocean Science Trust, Tony has led the development of Ocean Spaces, notably an online community to foster new knowledge of ocean health. And just a few years ago in 2018, he was selected to serve as a member of the US EPA's National Advisory Council for Environmental Policy and Technology. Currently, as program director for environmental informatics at SFEI, Tony represents 5 technical teams, a breadth of activity here, from geographic information systems to application development, to data services, IT systems, and for good measure, don't forget design and communications. Tony, thank you so much for joining us today, and we look forward to hearing about not only the unoccupied aerial system-based trash monitoring, but also the multiple ways how data can be used in California and for many other water and resource management applications. Tony, over to you.
Well, Meredith, Tara, it is a thrill to be here. I'm just going to share my screen. Can I get just a thumbs up if you can see my presentation? Okay, cool. So it is truly a delight to continue really an ongoing conversation, I think, with Meredith and Tara about some of these matters, and I'm really looking forward to hearing from all of you and having a fruitful back and forth discussion on some of this. This, I think, is really, it's, for me, at least I believe that the subject of this type of tool, a tool that opens up a new way of looking at the world and a new way of documenting and extracting information from the world around us, is so very powerful. It almost reminds me of that, the Spider-Man term, with great power comes great responsibility. So some of what you'll see today is almost a meditation on the opportunity, but also the challenges before us as we are embracing tools like this that fall under the broader umbrella of remote sensing, but have some special qualities that I think I would like to highlight. And if you come away with nothing else, I would really like you to at least understand the complicated pictures that tools like this can paint for us. Both in terms of the information they can yield, but also in terms of how they can be used for good and for not so good. And so I think we need to be very thoughtful about how to deploy these tools. So before I move on, let me go ahead and just tell you a little bit about the San Francisco Estuary Institute. We like to say that we bring the science for the public good. And what that really means is that we're thinking of the broader community of people who are interested in science for decision making. And we deliver that information through effective communication. And at least for today's topic, the most important part is through strong data. And that's really where some of the work that I lead comes in. So as Tara and Meredith mentioned, the Trash Monitoring Playbook is a project that was funded by the California Ocean Protection Council. Our partner in crime for this is the Southern California Coastal Water Research Project. Say that 10 times fast. And but we had a whole host of partners, including Meredith, through the research hub, the innovation hub, and those hackathons. But the goal of this, this project was to help support the 2015 trash amendments that were mandating drastic reductions in the amount of trash entering our receiving waters throughout California. So the need for consistent monitoring, the need for insight in order to see are things actually getting better when it comes to trash in our environment. That was behind the establishment of a library of standard trash monitoring methods, validating methods currently in use, and importantly for today's talk, exploring new and innovative monitoring methods. We really didn't want to just kind of do what's already, validate what's already in use. We wanted to take this opportunity to compare some of those methods to new ones, such as UAS-based monitoring. So some common concerns when we're talking about trash monitoring would be spatial comparisons. For instance, how does my stream compare to the trash in another county? How does this part compare to another? Temporal comparisons. Is trash in my neighborhood getting better or worse? Is trash in my city getting better or worse? Then community-based science, which is about empowering people so that the data that they are collecting can matter when it comes to decision-making. And so really that speaks a lot to this particular innovation. So the term that you're going to hear me use, some of you are maybe pilots for UAVs. But just so we have our terms right, I'm going to be saying today UAS, and that stands for Unoccupied Aerial Systems. And that is inclusive of the vehicle, plus all the software and the data that are kind of part of that whole thing. So it's kind of the bigger picture. UAV is just the vehicle, and then you'll also hear the term drone. So I'll be probably mixing and matching, but really for the most part, I'm talking about the entire system. So the broader categories of work that this can perform for us in the context of water quality monitoring are to serve as a data collector, to be out there collecting data by way of imagery, but then also a contaminant detector. And when I'm using the term contaminant, we could be talking about the freshwater harmful algal bloom, the lovely green pea soup you have here in Clear Lake, California, or you could be referring to trash. But then also, and I think this use is among the most important first steps, which is a documenter of the current status so that we can detect change. So even if we're not doing advanced analysis, just having documentation that is at a higher resolution and detail than we can get from your average satellite imagery could offer some real benefits. So I've been using the term water quality, and I know that at least right now, a lot of past presenters and maybe your world is concerned more with water supply. Water supply and water quality are not the same thing, though they do have a lot of overlap, of course, right? You want to make sure that the water you're consuming or through irrigation, through agriculture, through city services is clean and is of appropriate quality. But it's important to recognize that water quality and water quality monitoring looks at the entire landscape, because you do have the monitoring of non-point sources, and there's really no contaminant that's more exemplifying of the principle of non-point sources than trash. It's coming from various places. The actual source of the trash, the actual pinpointed source is unknown. So trash is one of those contaminants that threaten water quality, and that we are mandated to protect our water resources accordingly. So another concept here is that water quality protection includes ecological restoration. So the reason why I'm enumerating these bits of water quality for you is because it does have a direct bearing on the types of things you would want to do with a UAS that have to do with resource protection. So you can certainly use it to monitor infrastructure with relationship to water supply, but there is this opportunity also to use it in terms of water quality, and trash being a very visible pollutant is a classic, is a kind of a classic analyte to monitor. So if you see the image on the left, that is our GIS manager at SFEI, Pete Kahanen, a very capable drone pilot, and he has flying above his head his Mavic 2 Pro. The size is not distorted. It's about that size, so it's kind of about the size of your head when the legs of this thing are expanded out. So it's a very small vehicle. It is not an expensive vehicle. The equipment we use is off the shelf, unmodified, and we chose that deliberately because we didn't want, there are very sophisticated vehicles that cost upwards of $30,000 that can be deployed in the field. And then there are very sophisticated vehicles that fly by NASA and can fly at high altitude and great distances. But what we're concerned ourselves with are some very practically deployable solutions. This particular vehicle costs only about $1,200. So not out of the reach of a community organization, your average public agency, certainly. And so it's important to see that this is achievable. And but at the same time, one of the concerns we have is because it is so easily accessible, the use of these things are often confused with toys, right? Like you might have a drone that you give to a child, and that child can terrorize the neighborhood with this vehicle. This is not a toy. It is not meant to be a toy, but they look a lot alike, and they can be mixed up. So it is not a toy, and you can use a very sophisticated sensor as it has, but it's just a RGB sensor, it doesn't have any sort of NDVI or other kinds of multispectral or hyperspectral capability. But it is very practical, and it can be deployed in our environment for good purpose. So what you see on the right-hand side is an asphalt where you have all these little colors. Those are marking cigarette butts. So this was part of a test to see if we could detect cigarette butts against an asphalt background. And the answer, just spoiler alert here, we were able to achieve a 98% accuracy rate. So 98%. So that's pretty darn good. And it reflects this as a gold standard of detection. Cigarette butts against an asphalt background is pretty easy to count up all those cigarette butts. So that's a great thing. But another way that these tools are confused is sometimes when we use the term drone, people think of something like a predator drone, which you see here, militaristic. So on the one end of the spectrum, we have the confusion with toys. And then on the other end of the spectrum, we have the confusion with military, sophisticated military equipment that is designed to go into military action. So that's something to manage when it comes to the semantics as well as the use of these tools. We need to make sure that we steer clear of those uses. And you know, it's really easy once you put this out in the field to see some of the utility and why it's worth it to try to thread the needle between the toy and the weapon, because you can do so much more than what you could do otherwise. What you see here is the comparison of imagery that you can get on Google to imagery that you can achieve with unoccupied aerial vehicle or aerial system, UAS. So the important features to point out here is that the imagery that Google has is not a specific time of day. In fact, it's high tide, so the same terrain is inundated, and you can't see all the features of that mud flat that you can when you can fly at a specific time of day at low tide. So that's one thing, but also the resolution, of course, is so much better. And you can achieve 1/4-inch resolution with the UAS. So comparing again side by side, this is another highlight for the time of year. So I would assume that the kind of California yellow grasses that you see under the Google imagery is probably in the summer into the fall perhaps, but the springtime imagery in winter that you see there is important because sometimes you want to be able to fly at specific times. But the resolution really is remarkable. So here's a shot that we have, but when we zoom in, you can see that those dots are actually ducks. So being able to zoom in and achieve high resolution, it can get even higher than this. This was our first drone, And the sensor that we are using now that you saw dramatized earlier is 20 megapixels versus 12 megapixels. So, you know, it's a very sophisticated sensor that can achieve really high resolution. So some of the products that you can get from the imagery, it's not just pretty pictures, but you can get orthomosaics. Those are, you know, kind of taking pictures, stitching them together to have a very large image that you can lay upon a map. You can also get video, motion from that. You can have 360 panoramic photos, elevation data. Elevation data can't be, the value of that can't be underestimated. Some people call the structure from motion feature of these tools the poor person's LiDAR. LiDAR tends to be more expensive because it's a more sophisticated equipment. So if you can achieve regular snapshots of DEMs, of digital elevation models and digital terrain models, then that is fantastic. You can get point clouds, 3D models, contour lines, various things like this that can be critical, but pairing it with machine learning, you can extract even more information. I'll be getting to that later. You can use these tools with trash monitoring. We use them very often with restoration projects. You know, think about how powerful it is to have a before and after picture of restoration, to be able to see just what is the effect of restoration, not just the single before and after, but to see the progress over time, because restoration is a progress, not just a moment. To inspect infrastructure. So we've been called upon to kind of look at different infrastructure to serve for stormwater, et cetera, but also looking at events. So if there are events either predicted or having happened, you can get out there and document the event. Measuring sediment. Sediment has gone from a kind of disposable thing that you would want to ship away to things that are very, very critical. So the sediment that you'd find in stormwater channels, in flood control channels, at the bottom of the bay, all of that is so critical to just keeping our wetlands above, keeping their noses above the rising tides of sea level rise. So that's all very important. And then speaking to machine learning development, providing the imagery that's so critical for that, different forms of mapping, as well as for promotional materials. So some of the primary challenges would be professionalizing the field. What I mean by that is really speaking to the idea of the perception of it being a toy, and therefore inviting people into the field that may not have the training. And what we've been talking with a number of different municipal partners who ask us, so how do we do this? How do we deploy these tools? Because the picture you're painting is great, Tony, and we really appreciate it. But how do we get in the field? And we let them know that it does take training. And it's not something you just gonna go and buy the thing and then immediately deploy. So there has to be thought in some considering it as a profession. Clarifying the value of the tool and the data products. So thinking very carefully about how to control that story and tell that. Clarifying the regulations and rules. So this is a changing landscape when it comes to the rules and regulations that apply. So making sure that you're clear on those, and protecting personal privacy, right? So it's often thought that these things are spy tools, and it's really, really important to steer clear of that in practice so that you are protecting personal privacy. And also thinking now about managing the data distribution. So the products that come from the collection of these data, the products are numerous. So thinking about how to distribute the data. The raw data in this case would be just a single image, but then those images put together can make an orthorectified mosaic, an orthomosaic, but you can have a whole host of different things that emerge from there. You can have the process data, then also thinking about the metadata and making sure that that's attendant to all the data as it gets distributed. Demilitarizing the image associated with this tool is very important. We do not want people to think about these tools as threats, but we want them to think about the tools as complementing decisions that are key for us to make. And then finally, systemizing the use of the tools. So thinking about what systems can be put into place to make the tools easier to use, better to use, and more consistent in their use. So it's really important to think about it in terms of its system. And when I mentioned the term before, the unoccupied aerial system, I'm talking about that whole package. And we ended up using a tool that Esri later bought. It was 3DR, now it was purchased by Esri, called SiteScan. And SiteScan is an option. Drone Deploy is another one that people have success with. But we're more experienced with SiteScan, and it is not something we invented. It is not something that we modified. Rather, it is something that we've gone out and licensed. We find it to be very helpful because it helps with planning the flights. So you can just draw the area that you want to survey on a map in the field or prior to the flight, and push a button, and the drone goes off and flies according to that plan. Then you can save that plan and fly it again later. That's that kind of, when I mentioned the before and after restoration, but then also continuing on to the future, being able to refly the same flight again and again and again, the same altitude, the same area. That is a powerful longitudinal progression that can be very valuable and can give you great precision and accuracy over your impression of a landscape. But then also thinking about the processing and all the work that has to go into the data preparation, and that's something that the system can handle. Ground control points. So I know there are a lot of acronyms in here, I apologize, but GCP is ground control points. Ground control points help to improve the accuracy that you can achieve by marking certain spots on the image. Having web-based analysis, so instead of kind of doing all your own homegrown analysis, to have more automated routines that help with the analysis, and then doing online hosting and sharing. So being able to click a button to share your data. All of that is so very critical. We didn't see any value in us reinventing that wheel. This is something that continues to evolve and improve over time. So we found this tool to be very helpful. And this is something you could get yourself. So here's an example of a survey that we did on Corte Madera Marsh. All of those little white circles are marking individual images. Look at just how many circles there are. They're overlapping. And they're overlapping by design because they are stitched together to produce an ortho-rectified mosaic. And that, you might be wondering, how far is it from top to bottom? If you were to fly from this length straight across, that's about 3,500 linear feet. So that is quite a large area which we were able to fly. And if you were to click on any individual circle, you can pull up the image. So an individual image looks like that. And then you stitch it together and you can have a detailed image. Those little black and white symbols are the ground control points that you would deploy to increase accuracy, both vertical and horizontal resolution. And then from there, you can generate all kinds of things. This is highlighting the elevation. So this is a form of an elevation model. And here you can, the channels pop out because the channels are depressed relative to the green surface. So this allows you to generate that kind of poor person's LiDAR of the space. Here's another zoom in on an area, zoom in even further. So you can kind of see the resolution. It's not really the same thing that you're talking about when you're typically referring to, let's say, a satellite view. You can zoom in really far and have the benefit of a large area in certain cases when you've done these broader surveys, but also great detail. And then this is a three-dimensional model of the same terrain. So you can kind of stitch to, form a very complex three-dimensional model that you can manipulate in 3 dimensions. I'm not going to play this whole video. Sorry, I'm just doing a little time check. So I'm running a little bit late, so I'm going to hustle this up, but I just want to give you a glimpse of the types of things that you can achieve with video. So this is the same Corte Madera marsh, the same marsh you saw, except now it's been inundated. This is during a king tide event. And you can see in the distance, there's this infrastructure. So you might be flying this to see how high the tide is relative to those structures. But then if I zoom ahead, you can see that the water's right up against those houses. So this helps to tell a story. The video is not necessarily rendering data the same way that we might get from still imagery, but it is nevertheless helping to inform what's going on here. And this is a very unique perspective because, first of all, remember how I said sometimes the satellites don't fly at the time that you would want them to? You can fly exactly when you want to capture the king tide and tell the story of what's going on at a particular moment in time. So that's really valuable. So a quick word on metadata. So metadata is my thing. I'm often thinking of metadata, and the metadata associated with the raw photos is extensive. I can't list all the different attributes that is tracked automatically, but it is important to recognize that there's a lot of metadata that is associated with each individual photo. And all of that metadata really helps to maintain credibility and the scientific integrity of the data that you're out there collecting. This is another reason why this is not a toy. This is a professional tool if used correctly. And then when you are processing the individual imagery into larger pieces and larger data products, then you have processing reports that give you tremendous amounts of detail over how that was done. The reason why it's important to understand why the raw photos can still be of value, even if you have, let's say, that digital elevation model, is because you might need to go back. You might need to go back to the raw photos and reprocess them for different reasons. So it's important to maintain both the raw data and the process data. So I haven't talked a whole lot about our trash work, but one thing that we found is that trash is often more visible from the sky than the ground. You can see that we have our pilot walking ahead of us, and looking out at this terrain, it looked pristine. I didn't see any trash, and we were looking for it. So we were prepared to be disappointed. But then when we actually flew, we could spot trash kind of scattered about the landscape in areas that we couldn't otherwise see. So first of all, it was it's a very sensitive landscape, so we couldn't go traipsing about to find things. But so, you know, that's very important. But also we could see things that we couldn't see otherwise. So this is a tire that we could see. This is actually a low resolution flight because we were flying very high. We were flying much higher than we would fly in order to cover more ground. There's a bottle, a plastic bottle. And then here we are flying over an elementary school, and as all these vertices are marking detected trash. So this is where we are annotating this image to note where all the trash is found. The purpose for that is so we can feed it into our deep convolutional network. This is part of the artificial intelligence that we also pursue. I'm not going to talk much about that at this point, but know that that's one of the main things that we do use this imagery for, is for generating an algorithm that can detect trash automatically. And these are some of the confidence intervals that we had in detecting trash. It wasn't always easy. There were some very challenging terrain, which I can go into later. This is our effort to detect cigarette butts. So again, returning to that image that you saw before. And then here you can see those cigarette butts scattered about the landscape. This was seeded. So I don't want you to think that we just happened upon this place where there was a bunch of cigarette butts. We knew how many we were putting out there. We flew and we counted them. We can also document the landscape to assess change over time. And an important concept here is that you might have a purpose in going out to monitor for vegetation and invasive species, look for vegetative health. But having a library of imagery also means you can go back, and that's why that raw imagery might be very important, because you might need to reprocess it for different purposes. And so you might need to go back in time, look at those imagery, look at those data, and reprocess them to look for different things that you weren't planning to look for originally, because there's been some event, some erosion event, something has changed drastically and you need to account for it, such as this. So what we have here is snapshots over time of a restoration project where these are tree heights, some of which have been planted. And you'll notice that everyone is concentrating on protecting this part. And I don't know if you can see my mouse, but that kind of center part of each image. But what's happening up here is that there's tremendous erosion that was kind of unexpected, sloughing away at the edge of this riparian zone. And then some of it is being redeposited. And so having evidence of what was there in an area that we weren't really mindful of, but then coming back to it and being able to see what happened is so very critical. So it's about being able to leverage some of this imagery for unexpected purposes. Some of the current constraints on UAS, people are often interested in this, is that you have to maintain line of sight unless you have some specially high performance, NASA type of high elevation UAS. You need to avoid obstacles, trees, telephone poles. You can't not fly directly over people that are not part of your flight team. That's part of privacy protections. You cannot fly near airports and other secure airspace. And there are exclusion zones. So all of that is very important. And then you can't fly in very practically in heavily wooded areas because the tree canopy occludes the thing you're looking for, unless of course you're looking for the tree canopy itself. And then you can't fly in inclement conditions. You can't fly in heavy fog or rain. And one of the key things that we recommend is that you have an FAA licensed drone pilot. So you can get an FAA license, and we're happy to talk to you about how to empower yourself to do this work. And some of the biggest opportunities would be to detect trash as an integral component of a trash monitoring program. So it doesn't do everything for everyone to address every question, but barring the obstacles that you may face as enumerated in the prior slide, you can integrate it into your monitoring program. And being able to achieve a new high resolution library to document near and long-term change is tremendous. So we are in talks with cities who want to do trash monitoring, but they are also bringing in, let's say, their creek restoration experts, their environmental scientists who are doing that work, to understand how doing both essentially at the same time is a tremendous value, and the imagery can be used in different ways. So mining the imagery for both designed and undesigned questions, unplanned inquiries is important, and complementing related remote sensing tools. So you might wish to overlay the drone imagery over satellite imagery. So they can work in harmony with one another, and you can regard the drone imagery as an intensification of an area. And then feeding into a broader data distribution model for raw and processed data. And this is where I'm really excited for what the Water Data Consortium is doing in pursuing the data to inform decisions, because I think that this is going to be one of those complex questions all into its own, is how to harness these tools, how to harness the data that are derived from the imagery for purposes of decision making. So with that, I know I'm a little bit over, but thank you so much for entertaining my presentation.
That was awesome, Tony. Thank you so much. Really appreciate it. Yeah, exactly.
Thank you.
Yeah, and so I'm going to go ahead and encourage our participants to drop any questions that they might have either into chat or to go ahead and raise your hands. But I would love to just kick things off with a question that really you teed up. And then Luke, I see you just raised your hand, so we'll transition over to you after. But I think that you really teed up this question very well, Tony, at the end there, where you sort of alluded to the idea that there are opportunities for sharing these data more broadly, and really thinking about how do we take these data and really use them to enable decision making. And I'm curious just what your thinking is on that and how you see that advancing moving forward.
Yeah, so that is a great question, and there are many possibilities. The important thing, I said that you can plan your questions and then do your surveys, and I just want to make sure that people don't get the wrong message. You should still do that. So I'm not suggesting that you just go out and do your flights without thinking about what questions you're trying to answer, because the way that I would address your question, Tara, is that we do have to focus on what questions we're trying to answer when it comes to the decision making, because this is not going to be the solution for all of those questions, but it could be either a kind of background layer of information that can help to provide more context for what's going on. So as just by way of example, there are currently, trash monitoring programs out there doing their thing. They've been working steadily for some time. And sometimes people may look at the data that are rendered saying, this creek is getting better in its condition for trash. And some people might dispute it. Some people might say, you know what, that's not true. According to my anecdotal understanding, the creek is worse for trash. And you certainly have a lot of people with opinions about trash. But having a kind of a survey that goes out on a regular basis and flies the entire length of the creek can help to pinpoint exactly why people might have diverging views over the current condition of that creek. So it can provide that kind of background documentation. But also, if you can formulate your question in a way that is needing data that this can deliver, then what you can do is you can build workflows into the collection of the imagery so that you can regularly extract data that may be just numbers. It may be purely numerical. Examples being cigarette butts. How many cigarette butts are in this parking lot? You can answer that question. So if you can formulate your question in terms of, how many cigarette butts are in this parking lot, then you can use a tool like that to answer the question. But you do have to then think about the workflows, think about the relationship of these data to related data. And so it is part of a broader exercise to kind of put things in context and to put these data side by side with other available data.
That's great. Thank you, Tony. And Luke, do you want to go ahead and ask your question?
Gladly, thank you. Tony, this was really a relief of a presentation. I've been leading a semi-volunteer, semi-prescribed on-the-ground trash assessment here in Tucson on the Santa Cruz River, which just has a profound problem with trash. Based on the work that I had done back when I was in Washington, D.C., where they have some trash capture devices that were based on field assessments. But I'm part of a team of two, and we're relying on a lot of citizen science and other nonprofits to go out there and help us out. And recently, when our county was doing LiDAR flyovers, I was thinking, man, could we go out there and pair LiDAR with some on-the-ground trash assessments to try to understand not only how much is there, but what is there, because we want to try to design or purchase effectively trash capture devices for the headwaters to keep the trash from getting into the river. So just as a little bit of a background and also as a thank you, part of what we're doing is enumerating and qualifying what types of trash we're seeing. So are your sensors able to say, this is a cigarette butt, this is a candy wrapper, this is a styrofoam cup, a couch, things like that? Or is that part of what you're talking about with the learning that comes over time, that you're able to train the vehicles and the software to identify?
Right. That is that's fantastic. And I really, first of all, let me just applaud your work to protect your watershed. So it's people like you that inspire all of us. So that is a great question. We have two machine learning algorithms. One is tuned to detect cigarette butts and only cigarette butts. The reason why we did that is because we wanted to see, if you kind of just try to narrow what you're trying to find, what is the kind of gold standard of success you can achieve. And so with consistent backgrounds and a very narrow thing that we're looking for, we were able to achieve a 98% success rate. We have since expanded that one out to be able to detect cigarette butts on streets, in very challenging backgrounds like grass, and I even went to bark. I went to tree bark and I mean bark around trees, and took pictures because they looked a lot like cigarette butts. And we were able to achieve to extend success into those areas. However, let me say that our first experiment with detecting trash in creeks and rivers achieved only about a little bit over 50% accuracy. So that could be good enough for certain applications, but not good enough for something that is demanding a greater level of accuracy. But what our categories would be plastic, not plastic, or unknown. Those were are operative categories for that algorithm. The reason why we didn't get more refined to say couch or bicycle is that once you open up the door to all of those different objects, you need thousands of images of each one to train the algorithm, to be certain that you're accurate with and to be precise in getting down to those things. So that would require a higher lift. But just the being able to detect the trash, it could be still of good use to you, because what you could do is to pass the imagery through the algorithm. It then draws those boxes automatically around what it thinks are the trash. And then you have, first of all, a count of things that it finds. Then you could have someone who is doing the speciation of the trash. And I know I'm misusing the term species, but it is about kind of like classifying the trash according to whatever categories you might have. So that could then take the weight off of someone getting out in the field, and believe me, I know what that entails, and kind of categorizing each and every individual item. So that could be a good enough sort of solution for you.
That would be great. Yeah, because that's what we do. We have either a 10 by 10 meter grid or a 10 by 30 meter grid, and we enumerate everything. So what we come out with is a huge data sheet broken down by category, where each item in the category has a corresponding weight, which is what the DC group did. So now we know, hey, if we have a candy wrapper, on average, it's this. And so that helps us with what's there and what the total load is, so then we can create engineering solutions around that. But like I was saying, the process is so hard. So doing some sort of ground truthing on that fixed area, I think could help get us a long way toward what we're because we typically see the same things. It's sort of the basic floatables, and then the heavier, clothes and things like that get left behind. So anyway, I've taken up enough time. Thank you. I'll definitely reach out to you at some point, Tony. I appreciate it.
Yeah, and if you are interested, as it seems you are, Luke, you can go to trashmonitoring.org and see the field testing report, which is a lot more technical detail, and then the trash monitoring playbook, which is kind of designed for more of the general audience. So thank you.
Wonderful. It's so great to have this venue and the playbook and other resources to compare notes and trends beyond California to the region and the whole nation. That actually brings us nicely to one of the specific questions from Terry Biancardi in the chat. Terry is interested on the tip of their seat to have details about the drone system, whether that's in the site scan information. So Tony, do you have any additional pointers beyond trashmonitoring.org and the playbook for folks who would like to engage beyond today, or if they're listening to the recording afterwards?
Yeah, so certainly going to trashmonitoring.org is the place to start. You can, you'll see references to the two documents that I already mentioned. In the field testing report, you'll see all the details about the devices we use, the Mavic 2 Pro, site scan, and all of the specs on all those things, because there's, all those details. So I welcome you to look that up. And if you have any questions, there is a link on the page, or you can just write to me at tonyh@sfei.org. That's the simple answer.
Wonderful. Please keep the questions coming. I think, Tara, you had a next one that we got remotely about raw and processed data.
Yeah. So, Tony, you talked a little bit about the UAS imagery in the context of both the need for both the raw data as well as the processed, and really both the need for the metadata associated with that, but the ability that maintaining those as two separate elements provides you with a lot of flexibility in how you choose to interpret those moving forward. And so can you talk a little bit more about that distinction, how you've used it, and then how you could see that moving forward as you build this sort of system out and others build the system out?
Right. So the types of derived data that you get from the imagery are very diverse. You can think of the numbers that Luke was looking for. That is, how many cups are in this creek as a derived product from imagery that you can collect through the use of these vehicles. And it really does speak to the system as a whole, because as the vehicles are out there, they collect the imagery, they host the raw imagery, and then the raw imagery goes into a workflow where those images are stitched together to produce a mosaic. The mosaic is the most basic of products that is automated to come out of it. But then there's a whole range of other things that you could potentially do with it, but it requires more user input to inform the look and the scope of whatever analysis you want to do. Now, the reason why I bring that up is because it is often the case that you need to go back to the raw imagery to generate those derived products. And there are also times when we've flown an area and for whatever reason, the orthorectified image is off. It's like tilted and it's saying like, oh, this marsh was sloped by 40 feet, which is impossible. So there are sometimes problems that come up in the course of processing that need to be corrected. So having the raw imagery ready for reprocessing is always important. But then there's the whole issue of reproducibility and transparency. And it has to do with decision making, because you want to be able to show the line of provenance from the raw imagery all the way down to whatever sort of insight you're delivering, because the raw imagery themselves are quite frankly not that useful to most people, right? It's just an image. There you go. Here's a single image. But when put together with other imagery that kind of overlaps and all that, then it yields insights. And so having a line that is reproducible going from one thing to another is so critically important, especially then if you're going to use it in a scientific broader enterprise like a monitoring program, or if you're trying to make a decision from a management standpoint of putting in a weir here or beefing up this levee over here. So there's some real critical, almost like legally defensible steps you would want to take in order to make sure that you can always get from point A to point B. And also being very clear about whether this is raw or whether this is a derived product, because there is always a manipulation to get you from point A to point B. A good thing, but nevertheless a manipulation and someone's interpretation, either an automated interpretation or a manual interpretation. So that's all very important to keep distinct, is the raw imagery versus the analysis or derived products.
Building from that, Tony, you shared that one of the main uses for the data right now is automated trash detection, and that the team's recent work has focused on the development of AI, artificial intelligence, to detect trash and imagery. As you think about the next couple of years, I hesitate to go even beyond that, caveat the evolving landscape and context, but right now, sort of navel gazing a few years out, what are your hopes and concerns with respect to AI, and any insights that your team is seeing as they explore that avenue?
Yeah, this is, Meredith, this is where having some background in things beyond just kind of like technology is important, because I think we really need to be interdisciplinary when we're trying to answer questions about the broader implications of artificial intelligence. That is, it does have, if we ignore the fact that artificial intelligence can be abused, that it can serve the status quo or enforcing kind of decisions that have been made by prior generations, by basically just kind of recapitulating certain injustices. All of that is important to recognize, and so we just need to be continually asking ourselves, are we accounting for the ways that we may be unaware of those biases that go into the development of these tools. And trash is one such case where it is so aligned with poverty, not because poor people are less caring of their environment, but often because they are underserved by all the systems that are supposed to maintain proper collection of trash. And so we just need to make sure that we are not conflating people with trash, and that we are protecting privacy as we do this, and that we do not invite interpretations about surveillance. So as I think about the future of the artificial intelligence and the applications to this type of work, I do really hope that we can be as thoughtful as possible and as transparent with whatever assumptions go into the development of these algorithms, because these algorithms can be black boxes. They can be, in other words, things that not even the professionals know why this answer came out the other end of this black box. And so having the appropriate sort of auditing of the decision-making process is very important. Where we can go wrong, I think, is for a hasty adoption of systems that are very, very broad, and they are themselves empowered to make decisions. We want to make sure that we as people are making decisions, and that we're also looking out for those who are typically excluded from the process of making decisions, right? So we're trying to be as inclusive as possible, rather than imposing things on people. So that's a part of optics, but it's also real practice. You know, we want to make sure, though, that we are neither, in terms of optics, giving the impression that this is imposed on people lowest down, but also that we are in practice upholding those very same principles. So all of that is both hopeful in a sense, because I'm hopeful that people will be mindful of these things, but also concerned because we don't have great track records of embracing technology that empowers as much as it should.
And so I think we're going to leave it there in terms of the formal piece. So I'm going to just say a huge thank you to Tony for sharing the presentation and for the great responses and the like. Really appreciate you being here. We are going to transition to sort of the less formal portion of the discussion. And we have a few more questions related to AI on that topic. So please feel free to stick around. But for those of you who do have 1 o'clock, we'll be signing off. And just a huge thank you, Tony, for being here, and for everyone attending.
Thank you for having me.
Thank you, Tony. Thanks, everybody.
Thanks.
Thank you.
See you, Luke. And so with that, we have a question from Duncan, who is really interested in the work involved in the AI type analysis, and whether there are any community sourced analyses that you could point to that might serve as a starting point of the like. And Duncan, please feel free to jump in if you want to add any clarification or any additional comments on that.
Are you there, Duncan? Is Duncan still with us? Maybe Duncan. Oh, there.
They appear to be.
Yeah. If you're there, Duncan, when you say community sourced, I guess I wonder if you're talking about the raw materials that go into the development of a machine learning algorithm, or the kind of impulse and thinking behind the application of the algorithm itself. Are you able to clarify that either in the chat or verbally?
Hi, yes. I hope you can hear me. I was thinking of having the community look at the images and try to either identify what is trash, or perhaps even identify specifics of this is trash.
Yeah, that's great, Duncan. That's a fantastic question, and I think we are now at a point where that's a lot more feasible. Though I think we need to think also about the incentives for that, because I'm loath to ask for free labor unless there's a key benefit that would be conferred to someone who's doing that work. We just have to think carefully about not taking advantage, I would say, of people's goodwill. So ensuring that whatever is developed out of that effort enter into the public domain and be available for everyone to use, I think is really, really important. So there has to be infrastructure in place to facilitate the back and forth that you're talking about, setting up a set of imagery. iNaturalist is a mobile app that I know a lot of people love and a lot of people use, that helps to kind of crowdsource the identification of individual species. And that's kind of what you're talking about here, Duncan. And we are at SCPI, we're currently in conversation with the California Tobacco Control Program. And I probably shouldn't even be mentioning this, but we're in conversation with them about developing a mobile app that would kind of do a similar sort of ground truthing for trash items with respect to tobacco products specifically. And Literati has another tool that is really, really solid, very well proven. And so there are tools out there to do the crowdsourcing that you're talking about. But it first of all depends on how that labor is then leveraged and how the product comes out the other end. So I would want to look at that carefully before kind of endorsing that.
Along the same lines, in the chat, Rafael Rodriguez has a question about the trash identifying software or that workflow, if it's available to end users down the line, or your thoughts on what the broader community would be able to leverage and access.
Yeah, no, that's fantastic. So the tool is available. We developed this under TensorFlow 1.12, I believe, is the version that we used. TensorFlow is a convolutional neural network. It's really, it's for people who kind of know their way around code, but it is available to anyone to take and continue to evolve. And this is our trash monitoring algorithm specifically. So that is available if you go to trashmonitoring.org. There are references on there to the links to download the library of imagery, as well as the neural network itself. So the network is kind of the brain, and then the imagery is all of the raw materials that went in to help create that computer vision.
That's great, Tony. Thank you. And again, I'm going to encourage people, if they want to come off mute or raise their hands if they have questions, to go ahead and do that. But in the meantime, Tony, I was wondering if you could talk a little bit about how you're sharing the data from these analyses, what that's looked like, and any sort of both opportunities that have resulted from that, ways that people have been using that, as well as any challenges that you've faced and what that's looked like. Just really interested to hear more about that.
Yeah, so at this point, we are sharing a lot of what you might characterize as the raw data, right? All the images, because what we're trying to do is to share the imagery for people to continue to evolve the machine learning work. And what we faced, we don't want others to face, which is we didn't have any imagery that was suitable to train our neural network. So giving people a solid starting point is our primary goal here, is giving them a library of imagery that they can use, and they can take our neural network and continue to evolve it, or they can build their own. But all those images are available. So that's the kind of primary, the neural network itself and the data are the primary things we've shared. We could also share analysis, but there's no, again, it's about not having a question to answer per se. But what we have done is to take some of the imagery for other purposes, let's say restoration, riverine restoration monitoring, and we generate derived products that can, let's say, give a channel characterization. So it's really critical to, in terms of geomorphology, to know about the channel profile. And so to be able to do that using a drone rather than chains that you kind of string across the channel and measure the length with great time and commitment and professional resources, it's such a tremendous cost savings, and also very flexible. So we've already been doing a lot of that. And so in those cases, what we're doing is we share the derived product that speaks to the application that we're meeting. So that's going into the system, site scan in our case, and just sharing the imagery. And then that can be shared into a publication. It can be put into, just a link can be put into a publication or email. And so anyone can go and then see that, let's say a 3-dimensional model of a river channel. So that's another way that we've shared, is kind of opportunistically to meet specific needs and questions. But the raw imagery, that's available for anybody to take and do whatever they want with it.
That's really cool. Thank you. Are there other questions?
I guess if I can answer a question that hasn't been raised, someone might reasonably ask, how do I know if I can fly in this area or not, right? Because one of the hazards one might face is that you might be violating rules. You might be violating rules about airspace and the use of airspace. So you're not allowed to fly above 400 feet. That's kind of a more or less a hard and fast rule unless you have special permits to do so. But then where you can fit, fly in the landscape, that's often confined by, for us in the Bay Area, we're bound by a number of airports. There are 3 major airports in the Bay Area. That's SFO, San Jose, and Oakland airports, and they are right at the mouth of so many different tributaries into the Bay. Those are like prime areas where we would most want to fly. So it's unfortunate that we often can't fly in those areas because we want to see the trash before it makes it into the Bay, and that's like the best place to catch it. But we do use a tool called AirMap. AirMap is a good resource that can help to better identify the areas where you can and can't fly. It's very, very precise, and so you can fly kind of right up to the airspace where you're not allowed to fly, and that's and then other areas can be granted. You can be granted permission by FAA, by a control tower at an airport if you really needed to fly within the airspace of an airport. Again, I'm not advising people to fly near an airport, but if there is a compelling reason to do so, you can get permission to do that. But AirMap is the tool that we use, and it helps to, it uses something called low altitude authorization and notification capability, or LANC. LAANC is the acronym used. And so that's a vital tool in the toolbox of anyone who wants to fly legally.
That's awesome. Thank you, Tony. And I think that, one of the areas, and I think Meredith has a question after as well, but one of the things that we obviously as a consortium are really interested in is how do we harness sort of this collective energy? And as we see people collecting more and more highly detailed imagery, high resolution imagery, what do you see as some of the opportunities to sort of harness that to ensure that people are leveraging your expertise, leveraging their own projects and the like, and really putting that to serve sort of this larger effort and for greater purposes? I'm curious to hear your thoughts on that.
Yeah. So we are at this inflection point because, while I was bemoaning the idea that you have the perception of a toy on one end of that spectrum, it does speak to just how readily available these tools are. And so if people receive the training they need, it's such a low bar for entry that it's possible to empower different nonprofits, different community groups. It's better to think about it, I think, in terms of some level of organization. But if you empower people to get out there and just give them some guidance. So examples being, if you're going to be doing trash monitoring and producing imagery using these tools, we advise that you fly at 100 feet and that your sensor is 20 megapixels. So we can provide like a minimum specification that could then provide the the standards for collecting imagery and painting a picture of the landscape that's much broader than any one team could achieve on their own. Then the Water Data Consortium can play a role in certainly helping to incentivize that effort and to potentially even then harness some of the contributed data. I think that we just would need to think carefully about what the specific data format should be. So are you looking for the raw imagery? Are you looking for orthorectified images? Are you looking for some other derived product that others can commonly produce? But being really clear on what the format should be and what the minimum specifications should be for the tool they're using. It's not beyond the realm of possibility in the least to think about how an effort like this can build what we would call a synoptic view of the landscape. Because after all, one of the challenges about trash monitoring is that trash moves around. It's not like other contaminants that are more stable. You know, the lead you find in the soil is often there until it's been mobilized by rain. Trash can move around by wind, by rain, by people bringing it to different places. And so trash moves around. So having a broader view of the landscape would be powerful, not just for trash, of course, but it certainly would help to identify where the trash hotspots are, because what's a hotspot today might be another 100 yards downstream tomorrow. So having a broader view that could be produced through a really coordinated effort is powerful. Of course, the point in time is so important as well, right? When you're actually taking those images. So thinking about opportunities to incentivize people to do things all at once rather than kind of like spread out over the course of the year, so that you're mixing and matching different moments in time and you're unable to achieve that broader snapshot. That's also something to consider.
Tony, your comments about this broader view and the landscape over time really dovetail nicely to a final question that I had. And if anybody wants to, go off mute, we still have all of this extra buffer time. So please we encourage you to do that. In terms of this confluence, Tony, of data and the hardware and the societal context and backdrop, one of the key challenges that you mentioned was this idea of professionalizing the field, emphasizing the training, understanding and respecting the power and responsibility for working in this space. Yeah. And I think about the thousands of students, at least here in Berkeley, you can tell from my background, who are taking data science courses, many for the first time from all sorts of different disciplinary emphases. What are the opportunities or levers that you see in terms of cohesive training in this broader sense? And what would be your sort of asks to people tuning in or who have an opportunity to help shape the pipeline of potential innovators in this space? What do you see as an opportunity given where we are right now?
Yeah, well, Meredith, I'm really glad you brought that up, because data science as practiced at institutions like my alma mater, UC Berkeley, is very inspiring to me because it is multidisciplinary, if not interdisciplinary. It demands an awareness of a context for data. It demands that you think about policy and legality. These are all things that I think it leads to much deeper awareness of the context in which we find these tools and the ways that they might be deployed for good, and as I said before, for not so good. So I am hopeful that people who are trained academically in data science will essentially be much better prepared than someone like me for the world that awaits them. I think that they are coming into this with a sense of social justice, as is appropriate for this. Environmental justice is a big part of this. Trash is a big part of environmental justice after all. But the use of tools like this can be seen as a way to, I think, inform the levels of injustice rather than to carry forward the injustice. And so if the data scientists that come from programs like Berkeley and maybe even Stanford has a data science program, I'm just joking, they do, that it would be, I think that they have the wherewithal and taking into account a number of the different factors that that produce, we're dealing with black boxes. That's really important to emphasize, right? So I mentioned how the neural network is a black box, and even the site scan software that I mentioned before is in itself a black box. So there are elements of this that are opaque to us, where you have the raw imagery and then you have the products. And I mentioned that there's interpretations along the way. And so we need to be clear on where those areas that we can't see are and what assumptions go into that. And that's really where a data scientist always needs to be aware of those assumptions. And I remember going to a data science conference at UC Berkeley just a few years back, where they emphasized the distinction between repeatability and reproducibility, and the need for that in the context of scientific labs, and the hazards of neglecting reproducibility that we really need to bear in mind, that we need to be able to reproduce all of our findings. And so that really stuck with me, and I think that people who are trained not just in an engineering point of view, but with a wider breadth of ethical considerations, I think will be prepared to take this on.
So what a nice way to synthesize all of that. Really appreciate the thought and that you bring to this, Tony. Really fantastic comments. Are there any other questions? All right, if not, then I think we'll say a huge thank you to Tony and to Meredith. Thank you. Thank you to Amanda, who brings all of these, makes all of this happen. And we'll look forward to seeing you all in August.
Thanks for having me.